Okay, so let's have a look at the Junior Certificate Higher Level Maths Paper 2 for 2018, question 6. 16 girls and 14 boys went on a school tour to Barcelona. The weight of each student's bag in kilograms is shown in the table below. So we have girls and boys here. Now, the weights here are in order from 5.8 up to 11.3 and from 5.9 up to 10.6. So the mean weight of the girls' bags was 8.6 kilograms, correct to 1 decimal place. Work out the mean weight of the boys' bags, correct to 1 decimal place. So this is just a list of numbers, so we just got to add them up and divide by 14. So let's do that. So we got to take 5.9 plus 6.8 plus 7.4 and so on. Come down here, plus 9.7 plus 10.5. So you got to add all these up, and we've got to divide by 14, and this is equal to our mean. So that equals, when you do that, you can do that on your calculators, you get 122.2 when you add up the top line. You divide by 14, and that gives you 8.7 kilograms to 1 decimal place. And that's it for part A. So let's have a look at part B. Use the data in the table above to complete the following frequency table. So here, this is a grouped frequency table, so we don't have all the individual values, but we're just grouping them into weight groups here. So we have from 5 to 6 kilograms, from 6 to 7, 7 to 8, and so on. And we have the frequencies here. These are the girls' bags, these are the boys' bags here. Now, I've done this already, and I found that I got 3701, 3701. And on the bottom here I got 1, 1, 1, 4, 6, 1, 0. But you just simply count you count the number of weights here between 5 and 6, for example, and you put them in here. The number of weights for the girls between 7 and 8, and you put them in here. Now you've got to read this little statement down here at the end. It just says 5 to 6 means 5 kilograms or more, but less than 6. In other words, if there is a bag that weighs 6 kilograms, it doesn't go into this cell here, it goes up here, and so on. It's the same for all of them. 9 to 10 means 9, but not including 10. If there is a bag that weighs 10 kilograms, it goes in here. Okay, now Owen says in general the girls took heavier bags than the boys did. Based on the data above, is Owen correct? Give a reason for your answer. Now, you've got to look at the statistics for the boys and the girls. What we're going to do here is look at what's called measures of central tendency, or just means, really, mean, median. I'm going to look at the mean and the median. So we know that the mean for the girls, it was, we were given that at the very beginning, and it was 8.6 kilograms. The mean weight for the boys, when we did that, we got 8.7. So you can see immediately there that Owen doesn't appear to be correct, because the boys' bags are slightly heavier, although there isn't much of a difference here between the two. You can also work out the median, so the median for the girls. The median for the girls works out at 9.1 kilograms. That's the middle number, and the median for the boys, then works out to be 9 kilograms. So again, there's very little difference here between the two. The range is a matter of interest. So the range for the girls is 5.5 kilograms, and the range for the boys is 4.6 kilograms. So there is a difference in the range, all right, but what we're interested in here really is if the girls took heavier bags than the boys in general, or on average, if you like. So I would say here that Owen is incorrect, as there is little difference between the mean and median weights of bags for girls and boys. If we were just to look at the mean here, you could say that the boys are slightly heavier. Median, you would say that the boys are slightly lighter. So I think overall there isn't much of a difference between the two. Okay, so that's part C. Let's have a look at this part here, part D. So we have the table below shows the length of time it took students to get through security at the airport. So you're given again a grouped frequency table here, and the time is in minutes. Now again, 5 to 10 means 5 minutes, but less than 10. So 5 minutes here would go into this column here rather than this one here. Draw a histogram to represent the data. Okay, so they give you this little axis here, and you've got to draw the histogram based on this. So let's see, we have, I'm going to go back and forward here. So we have 0 to 5, 5 to 10, 10, 15, 20, 25, 30. So we have evenly spaced groups here on the x-axis. So these values here are going to go on the x-axis. So we're going to go out to 30. So let me see. 5, 10, 15, 20, 25, 30. Let's say 5, 15, 20, 25, 30. I'm going to take 4 here. Let's see, we'll do it in black here. So I'm going to go 1, 2, 3, 4. So from out to here, I'm going to say is 5, 0 to 5. 1, 2, 3, 4. I'm going to say this is 10. 1, 2, 3, 4. I'm going to take this as 15, and so on. 20, 25, and 1, 2, 3, 4, 30. Okay, so on my y-axis then I need to look at values between 0 and 11. So I'm going up here, I have to go up here to 11. So let me see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, I might just take individual boxes here. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 here. Now, let me just do this properly. 9, 10, and 11. Now, the other thing you've got to do here is make sure you just label the axis. So we have time here in minutes. And on the y-axis then we're going to have number of students. So this is number of students. Okay, so we've just got to draw the individual bars then. So let's see, from 0 to 5 we've got to go up 4. So 0 to 5 we're going up 4. So you got to go across here, from 4 and then down. I'm doing this freehand. You can use a ruler. From 5 to 10 we're going to 8, so let's go to 8. So you got to go here. Okay, let's see, from 10 to 15 we're going to 11, so we're going here. Let's see, from 15 to 20 we're going to 6, so we're going here, 6. And 20 to 25 is 0, so we don't have to do anything with that. 25 to 30 is 1. 25 to 30, we just go up 1 here. Okay, so this is our histogram. Obviously, when you're doing it, do it using a ruler. So, and you can do a little and fill them in here if you want. Okay, and that's it. So there's our histogram. Now, so normally what you can do here as well is just put in a little little key here as well. With histograms, you could just say something like this is equal to 1 student. So this area here would represent 1 student. Okay, so let's look at the next part of this question. The table below shows the amount of money that the 30 students spend at the airport. So again, it's a group frequency table, so we have 0 to 5, 5 to 10, 10 to 20, 20 to 30, 30 to 50. So the groups here are different in this particular case. They're not all evenly spaced. So, and again, the little note here just says 5 to 10 means 5 but less than 10. Now, use mid-interval values to estimate the mean amount of money spent. Give your answer correct to the nearest cent. So we've got to work out mid-interval values here for each group. So let's just write out our mid-interval values. So our mid-interval values are going to be 0 to 5. You can add them and divide by 2. So 0 plus 5 divided by 2 is going to be 2.5. You got 5 to 10, well, that's going to be 7.5. You have, let's see, 10 to 20, well, the mid-interval value there is just 15. You have 20 to 30, well, that's going to be 25 is the mid-interval value there. 30 to 50, well, the mid-interval value there is 40. 50 to 75 or to 100 is just going to be 75, and 100 to 150, the mid-interval value is going to be 125. So we've got to work out the mean using these mid-interval values. So your mean then is going to be, what you've got to do is multiply the frequency by each of these mid-interval values. So it's going to be 5 times 2.5, and you've got to add them all up. 4 times 7.5, you got 7 times 15, you got 8 times 25, you've got 3 times 40, you got 1 times 75, and finally then you've got 2 times 125. So that's our top line. The bottom line then is just going to be the sum of the frequencies. So you got to add up all the frequencies. So it's 5 plus 4 plus 7 plus 8 plus 3 plus 1 plus 2. Now this is all just a lot of calculator work. So you can do the top line, you can do each individual one and then add them up. I'm going to skip a line here and just write down what I got when I added up when I worked out the top line. So it was 7, 292.5 on the top line, and the bottom line is just going to be 30. There were 30 students. Okay, so all we've got to do is divide these top by bottom then, and you end up with an average spend of 26.42 euros. Now that's to, remember they asked to give it to the nearest cent, so this is the nearest cent here, to the nearest cent. So that's it. That's it for E. Now let's have a look at the last part of this question. Use the values in the table to estimate the median amount of money spent as accurately as you can. Justify your answer. So the median is the middle number. Now it says here, remember that there were 30 students. Now normally what we would do is take the 30 students, divide by 2 to find the median. We would get 15th. So we would have to take the 15th and the 16th number and add them and divide by 2. Now if we look at our table here, we have the amount spent in euros, and we have, what I'm going to do here is write down what's called a cumulative frequency. I'll just explain what that means in a minute. Now what I'm going to do here is just have a look at this table, and I'm going to take this value here, 5, 10, 20, 30, 50, 100 and 150, and I'm going to just write down here the first case. I'm going to look at the number of people who spent less than 5 euros. Then I'm going to look at the number of people who spent less than 10 euros, less than 20, less than 30, less than 50 was the next one, less than 100, and the last one was less than 150 euros. Now if you look at that, the number of people who spent less than 5 euros was 5. So I'm just going to put that here. Just explain why I'm doing this in a minute. Now if we look at the number of people who spent less than 10 euros, well, these people spent less than 10 and these people spent less than 10, so that's a total of 9. So 9 people here spent less than 10 euros. It includes these 5 here. How many people spent less than 20? Well, less than 20 would be these 7. These 4 spent less than 20. These 5 spent less than 20. So that's a total of 16. That's a total of 16, which is important in this particular question. 16, and so on. And these numbers, I'll do the other ones. 24, 27. There were 28 here, and then all 30 spent less than 150 euros. Now if you have a look at what we did at the start here, we said we had 30 people. To find a median, divide by 2, that gives us 15. So we've got to take the 15th and the 16th number, we've got to add them and divide by 2. Now our 5th number would be up to 5 euros, 9 numbers go up to 10, 16 numbers go up to 15. So in other words, when we get to here, we have 16 numbers. We have these 5 students, we have another 4 students, that's 9 students in total, and then we have these 7 students. That's 16 students have spent up to 20 euros. So 16 students have spent up to 20 euros, or less than 20 euros if you like. So that's kind of vital in this particular question, because we're looking for the 15th and the 16th student. So we know that the 15th and 16th student spent less than 20 euros, and probably the 16th number is going to be close to 20 euros. I don't know exactly what it is, but it's probably going to be somewhere close to 20 euros. So in this case it says use the values in the table to estimate the median. So we're only estimating, we're guessing here reasonably what the median would be, as accurately as you can. Justify your answer. So we're going to say, I'm going to say that it's going to be, let's say it's just less than 20. Let's say it's going to be 19 euros. I'm going to say the 16th number is probably going to be 19 euros. So I'm going to say my median is equal to 19 euros. Now, justifying the answer then, well, this is partly it here. The median is the mean of the 15th and 16th 16 value or data. As 16 students spent less than 20 euros, I'm saying €19 is a good estimate of the median. As the 16th number is probably close to 20 euros. Okay, and that's it for this particular question.